Hello everyone, welcome our YouTube channel Euclid Mathematics. In my group theory series of lectures, we are here with the cyclic or non-cyclic subgroup. In my today's video, I am going to explain here how to find cyclic or non-cyclic subgroup of our given group using previous year question from CSIR NET. These topics are very important for different type of competitive exam like NET, SET, GATE and at the college level also. In my today's lecture, I will explain short way to find out the cyclic subgroup of any group. In my previous lecture, I also explained to finding the cyclic subgroup in quaternion group. Okay, so in my today's lecture, I will explain an example from CSIR NET which asked in CSIR NET for 3 marks. Okay, very easy question. We just need to remember only 1 or 2 fundamentals. We can answer that one very easily. If you practice more and more, you can answer by observations only. Okay, now let's read our question. G is given Z3 cross Z15. Okay, so Z3 cross Z15 is the integer group given, and H is a subgroup of order 9. Okay, our group is having subgroup which has order 9. Okay, and it is the H. Okay, and we have to figure it out which one of the option is correct here. First is Z9, second Z3 cross Z3, third Z9 and Z3 cross Z3, both are possible, and fourth is a none. Okay, because of that question is for 3 marks, so we have to check which only one option which is correct. Okay, so we have to check whether that group is having isomorphic group. H is subgroup of G, and which is isomorphic to which one of the group is that one. Okay, so H is a subgroup of order 9 which is given in our example. Okay, so that means our subgroup which is having order 9, and we have to find out which one of the group which is isomorphic to the order of 9. Okay, because H is isomorphic to order of 9, that means we have to find out the group which is isomorphic to order 9. Okay, so let's find out the which group is isomorphic. Here order of H is 9, then which is isomorphic to 2 different group. Okay, 9 order group is isomorphic to Z3 cross Z3 or only Z9. Okay, this is cyclic, this is non-cyclic. Okay, so we have to find out which one of the option, which one of the group which exactly our H is isomorphic. Okay, or both of the Z9 Z3 isomorphic to H. Okay, now it's the easy way to find out any group which is isomorphic to other group. Okay, first of all we have to check their element of order. Are their element of order same or not? Okay, next we have to check the group of order is same or not. We have to, after of that, we have to check their subgroup whose order is same or not. Okay, so we have to check this way. Okay, or an abelian or non-abelian, this property we have to check whether these two groups are isomorphic to each other or not. Okay, so here it's the easy way. Always we have to remember, for finding any two subgroup are isomorphic, we have to check only the element which present in both of the group. Okay, their order present in both of the group. This is the easy way to get the answer in short time. Okay, in our exam we have limited time, so that's why. Okay, so here Z3 cross Z3 and Z9, let's find out which one of the isomorphic. Okay, so we have to check Z3 cross Z15, this group is isomorphic to each one of them. Okay, so here Z3 contains 0, 1, 2, these 3 elements, and Z15 contains 0 to 14, these elements. Okay, and we want their cross product and the element of order present there. Okay, so we know that for finding the element of order Z3 cross Z15, we have to find out their order by using LCM of their different elements. Okay, first of all, find out the order for 0, which is 1 under Z3. Find out the order for 1 under Z3, which is a 3. Why 3? Because identity element in under Z3 additive group, which is 1. Okay, so when we take the power 3, so 1 to the power 3 is 3 into 1. Okay, and 3 1 into 1 is a 3 under Z3, which is a 0. Okay, so similarly for order 2 element whose order 2 to the power 3, 3 to the 6, 6 under Z3 is a 0, 0 is identity element. Okay, these are the element of order from Z3. Similarly for element of order from Z15, 0 is order 1, 1 is 15, and similarly remaining element you can find it out. Very easy is that. Okay, so now take their LCM. LCM 1 with 1, 1 with 15, 1 with 3, 15. So we have to take their LCM. Okay, and find out that LCM contain which element. Okay, so that LCM contain which element, and these elements are present whether in Z3 cross Z3 or Z9. Okay, so if it is not, some elements are present here and it is not present in one of the group, that means that group is not isomorphic. Okay, so here Z9 contains the element of order 1, 15, 5, 3, 10. Okay, and 1 is the element whose order 9. Okay, we can easily say that 1 is the element whose order 9. So 9 to the power 1, 9 into 1, and under Z9 under additive group it is identity 0. Okay, 1 is the element whose order 9, but Z3 cross Z15 is the group which do not contain the element whose order 9. Okay, so we can observe here we do not have any element whose order 9. Okay, so that means our group which not isomorphic to Z9, okay, which is not isomorphic to Z9, that means obviously it is isomorphic here. So you can check by using their cross products and their elements. Okay, so Z3 cross Z3 contain those elements of order which contain in Z3 cross Z15. Okay, That means all element of order present here, which is present here. Okay. So I hope so this one is easier to understand. Okay. So for finding the equivalent subgroup, we need to know first of all how to find the order. Okay. But it's easier. Okay. Now let's go for the further. So H, when H is isomorphic, that means Z3 cross Z15, which is isomorphic to 9, then H has element of order 9. Okay. But we know that our group H is do not have element of order 9. Okay. So that means Z3 cross Z15 has no element of order 9. Okay. But Z9 is element of order 9. That means H is not isomorphic to Z9. Okay. And if H is not isomorphic to Z9, then it left over here H is isomorphic to Z3 cross Z3. Okay. If it is isomorphic to Z3 cross Z3, that means it has element of order, highest order, which is a 3. Okay. Which contain in our Z3 cross Z15. That means our Z3 cross Z15 has the element of order 3, and H is our group Z3 cross Z3. Okay. Whose element of order which contain in Z3 cross Z15. Okay. So these both are subsets. Okay. That's why we can say that H is isomorphic to Z3 cross Z3. Okay. So in our option, what we have given, now let's check out. So in our option, it is given which is isomorphic to Z9, but we found here Z9 contain element of order 9, but Z3 cross Z15, it does not contain element of order 9. If any group which does not contain element of order 9, that means it do not have subgroup of that order 9. Okay. So Z9 is not isomorphic to our group G. So exactly in our option second, Z3 cross Z3, which is isomorphic to Z3 cross Z15. Okay. These both are equal. Okay. Isomorphic. So, but in third option, Z9 is given. Z3 cross Z3 hold, but Z9 does not. Okay. So option third wrong, and none option fourth is also wrong. Okay. First, third, and fourth, these three options wrong, and option number second, which is correct. Okay. I hope so you all have understood my today's lecture. So thank you everyone.